Hi there, I'm KM, an associate professor of the Chinese University. Here, we have a few videos in a series of biochemistry and public health on air pollution and health. This video is on the air pollutants and where do they come from. There are other videos on the air pollution health index, toxic effects of particulate matters, and how air pollutants cause lung cancer. The air pollutants and where do they come from? Most of the air pollutants affecting our health are from transportation, close to half of them, but around 25% could be from a stationary source of combustion, 15% from industry, and a few from solid waste combustion or incineration. These data are from a US city, but similar in cities around the world. Remember the old days we had much diesel engine exhaust polluting the roads. The chemicals involved are mainly carbon monoxide, sulfur oxides, volatile organic compounds, nitrogen oxides, and the suspended particulate matters. There are two types of air pollutants, primary and secondary. For the primary air pollutants, here are the basic 7 primary pollutants per heat. The oxides of carbon, sulfur, nitrogen. Sulfur dioxide mixing with water in the air to form acid rain. There are also volatile organic compounds, including methane, benzene, formaldehyde, and chlorofluorocarbon CFCs. The suspended particulates, total and respirable particulates. The last two are radioactive substances such as radon-222, plutonium-239, and heavy metals such as lead, cadmium, and chromium. There exists also secondary pollutants from primary pollutants as they mix with oxygen. Sulfur and nitrogen oxides would form acid rings, affecting not just human health, but also damaging stone or architectural materials, as they are corrosive. Photochemical smoke formed after UV light irradiation producing hydrogen peroxide and ozone in photochemical smoke are also irritating and corrosive. Finally, the PAH or polyaromatic hydrocarbon or polycyclic hydrocarbon are cancer-causing agents that we should avoid as far as possible. Why do we so worry about air pollution? Because air pollutants can kill and could cause chronic diseases. The most well-known disease relating to air pollution is asthma. Asthma is not caused by air pollution. Asthma is an inflammatory disease of the lung, leading to narrowing of the airway. Sulfur dioxide or other chemicals can induce the complications of asthma. Bronchitis is also commonly associated with air pollutants, which lower the lungs' immune response to microorganisms, leading to infection of the bronchus in the lung, and hence bronchitis. Carbon monoxide, nitrogen oxides, and particulates affect our pulmonary and circulatory systems as well. Other conditions include discomfort and eye irritation due to the corrosive nature of the air pollutants. Finally, inhalation of diesel suspended particulates or other fine particles and cadmium from cigarette smoke are well-proven carcinogens causing lung cancer. Therefore, we have to carry our continuous monitoring of the air pollutants and establish some air quality objectives, AQOs, for sulfur dioxide, total suspended particulates, respirable suspended particulates, nitrogen oxide, carbon monoxide, ozone, and lead. The 7 major air pollutants leading to severe chronic diseases and health complications. We monitor these air pollutants in our monitoring stations at the rooftop level as shown in this diagram in Sa Tin. There are a total of 13 general stations covering other areas in Hong Kong, and also the street levels of Central, Causeway Bay, and Mong Kok are the 3 roadside stations. The AQOs for the aforementioned chemicals are set as 100 for the air pollution index. We use any of the highest to call it the API, air pollution index, as any of them is harmful. Highest API values could reach 500. It happens in elsewhere when volcanoes blew out. API is commonly used around the world, and we can click into the links here to read the real-time air quality index, AQI, around the world, from Hong Kong to China and the cities around the world. We can estimate the total outputs of the air pollutants in Hong Kong, and our power stations are the major sources, with the incinerators from burning fossil fuels for electricity production. We have the Castle Peak and Lamma Island stations from the 2 companies. The third one is an incinerator for burning of special chemical waste at Tsing Yi. We put them far away from the city centers, and they have little direct effects of our health. Started from 1991, the Castle Peak station used low NOx coal burner and later other emission facility to reduce much of the air pollutants over 50%. We are moving towards more natural gas from 1/3 to half or even more, and expecting to see the reduction of air pollution from these stations. The best option is wind power, which uses no gas nor producing any air pollutants. While the local consumption of electricity is in the rise, with 40% higher from 1997 to 2015, major emissions of SO2, NOx, and the particulates are dropping. Carbon monoxide unchanged, and volatile organic compounds increased 20% over the last 2 decades. This slide shows data from the Environmental Protection Department, EPD, of the Hong Kong SAR government. The various air pollutants and their sources. In 2015, as you can see, at the bottom, electricity generation contribute only a small portion, except for sulfur dioxide with 37%, yet the major source of carbon dioxide was from navigation or marine vessels. In fact, navigation was not controlled for what they emitted. It has become the major sources of NOx, RSP, and FSP, fine suspended particulate. Road transport or vehicle emission is still the major source of carbon monoxide, CO, as you can see in the far right column, up to 51%. These 4 charts show the trends of emissions from 1997 to 2015. As you can see that the total emissions are falling, mostly now only 30% from their peaks, except for NOx, still more than half from the peak, and navigation is still the major contributor, following with power generation and road transport. The data of road transport as expressed in vehicle kilometer traveled is in the rise, with close to 20% from 1997. The emissions of air pollutants dropped to zero for sulfur dioxide. Particulates dropped to below 10%. NOx, carbon monoxide, and VOC, volatile organic compounds, reduced to 40% of the 1997 level. However, while major air pollutants have been dropping significantly, the visibility trend or bad air days are getting worse. Over the years, with over 1,000 hours per year, that is a few hours per day. You may notice that in recent years, cross-boundary air pollution is serious and very serious. This diagram from EPT released in 2005 shocked everyone, as you can see that the whole southern Canton, Guangdong province, was packed by high aerosol content indicated in red. Transboundary air pollution are from both the air emission in Guangdong and vehicles in Hong Kong using fuels from mainland is also a major concern. In recent years, smog from northern China is also affecting us. This data over 2016 December reported by Japanese, showing the smog could move out from China into the East China Sea. In 2017, smog from central China also spread down and becomes more serious than ever. Burning of coal is the main cause. On the days following that, you could see the API in Hong Kong version, and it was contributed mainly from PM 2.5, the fine respirable particulates covering Western Hong Kong. With this, we reviewed the component, the source, and impact of local air pollution in this video. I hope you now understand the situation. Please continue on our next video about the Air Pollution Health Index.